In today's session, I want to continue on the video series on implementation. In today's session, we're going to talk about an actual case study with the project I'm working on currently and what results we've achieved. And our focus is just achieving stability. So the last few sessions, we've really talked about getting that breakthrough improvement and achieving stability. So what does that mean? So it means that the system is predictable. So I have this data here from an actual company, and the data that we are looking at is the number of work orders and how many days it took those work orders to get through their system. So on the left-hand side here is the number of days, and then you see the data of how long it took work orders to get through the system, and each data point here is a work order. And so when we start looking at the data, we see lots of variability. So, and I see all these red points above our upper control limit, which are special cause variations. So we had some jobs that went through in a day, some jobs as much as like 17 days. Okay, so we had huge variability. But when we take that data and we analyze it, what we see is that this data set right here that I'm showing, the average days for jobs to get through the system, excluding all these points in the red, was 4.42 days. And 3 standard deviations above the average, 3 standard deviations below the average gives us our 6 standard deviations, and it's 9.4. So we had an average of 4.42 days with a standard deviation of 9.4. So the first action we took after we did the planning of the whole value stream and understanding how to design the value stream and how to design flow, the first thing we did is reduce the batch. So we reduced the batch size of the work order from 300 units to 200 units. Now, by doing that, what that does is that increases the velocity of that work order by 50%. So if you understand the impact of batch size reduction and what impact that has on the system, it improves velocity. So when we did that, you can see here, this second circle was when we just cut the batch size. So you can see our average days to complete a work order went from 4.42 to 2.65. And the standard deviation, 6 standard deviations cut in half almost to 4.39. So significant reduction in variation, significant reduction in the average days to get through the system. So that was the first thing we did, is cut the batch size to start increasing the velocity of the work orders through the system. Then we implemented simplified drum buffer rope. So if you're not familiar with simplified drum buffer rope, it's a theory of constraints technique for scheduling. And what we're doing is we're taking the demand rate of the customer, we're backing off by a reliable lead time, and we're releasing work orders a reliable lead time before the due date. And in this case, it's make to stock. So what we did is we set up a time buffer. Instead of using a time buffer, we're using a stock buffer. And we're determining how much inventory should be in the system based on the demand rate and the number of units, reliable lead time to get a job through the system. And so when we implement the SDBR, what we see here is significant reduction in variability and significant reduction in the time to complete a work order through the system. So now we're looking at average of 1.66 days from start to finish through the value stream, with 6 standard deviations of 1.69. So when I've been talking about breakthrough improvement, this is what I'm talking about in breakthrough improvement. So the batch size reduction was done. About a week and a half later, we implemented the SDBR, and we went from 4.42 average days of a work order through the system to 1.66. And then we reduced the standard deviation, 6 standard deviations, from 9.4 to 1.69. That's breakthrough improvement. So what's the implications for the customer in this case? So now we've freed up about 2/3 of the inventory in the system. So there's 2/3 less WIP in the system, which converts to improved cash. The on-time delivery is gone up significantly. So the customers, an internal customer in this case, hasn't seen a stock out since we implemented the system, and we're holding much less inventory. And the velocity of the work orders is significant. So now quality issues are found earlier. And then we did some process adjustments. We took out some non-value added steps in the process to even improve it more. and we've gotten unbelievable results. Now the plan is to roll this out across all the other value streams in the organization. So within months, we're going to see huge improvements in both flow, operational improvement, effectiveness, cash improvement, on-time delivery improvement. So that's the importance of achieving stability. So that's our session for today. And I wanted to show this case study because this is what we're talking about of breakthrough improvement. So if your organization is looking to get this type of breakthrough improvement, give us a call. We can walk you through the process step to achieve this and improve business outcomes and improve performance of the organization.